This is part 1 of our lesson on solving equations by isolating the variable. So there are lots of different strategies for solving equations. The one we're going to talk about today is where we are rearranging to get the variable in the question by itself. So we're going to start with some polynomial equations in this part, and then we'll do some trig, and then some log functions, and then some exponentials. So when I'm solving, I am trying to find the value of the variable that makes the equation equal on both sides. So we're going to start with the question, 8 times 3x squared minus 10 plus 7 equals 14x squared plus 87. So when I look at this question, the first thing I notice is that there are actually two variables that show up in this question. So they're both x's, which is good, but it does show up in two places. But I also notice that the two variables have the same exponent, which makes them like terms. So as long as those are like terms, I could solve this by rearranging as long as I collect up my like terms first, and then I can rearrange and solve. So when I'm looking at this question, I notice that there's a bracket. So I would start by multiplying the 8 into the bracket so that the bracket isn't there anymore. So I would multiply 8 by 3x squared and 8 by negative 10. 8 times 3 is 24x squared. And then 8 times negative 10 is negative 80. And then I still have a plus 7. That was not in the bracket, so I don't multiply it by 8. And then that equals 14x squared plus 87. So when I'm solving by isolating the variable, that means we want to get the x by itself and everything on the other side. So what I would like to do is I would like to try to get the two terms that have x squareds on the same side of the equation. So I would start by moving either the 24x squared to the right-hand side or the 14x squared to the left-hand side. So I'm going to pick the smaller of the two, which is the 14x squared, and I'm going to subtract 14x squared from both sides. I do the inverse operation, right, to get it to the other side. So 24x squared minus 14x squared is 10x squared. And I am going to collect these like terms together that are on the left-hand side. I have negative 80 plus 7, which would be negative 73. And that now still equals at least the 87 that's on the other side. From here, I would like to get the x alone. So when we rearrange equations, we use the reverse order of operations, meaning that we're going to move any addition and subtraction first, then multiplication, and then exponents, and we already dealt with the bracket. So I'm going to start by dealing with my addition and subtraction. I'm going to add 73 to both sides. So I get 10x squared equals 87 plus 73 is 160. Okay, we still have multiplication and an exponent. Multiplication would get moved next. So I would divide both sides by 10. So 160 divided by 10 is 16. So x squared equals 16. And then to cancel out the square, I would do the opposite and square root. Now, when I square root, the square root of 16 is 4. But because this is an even numbered root, it could potentially be positive 4, but it could also potentially be negative 4. So there are actually two solutions to this question. Either x could equal positive 4 or x could equal negative 4. You can write it out as two separate answers, or you could just write it as plus or minus 4. All right, we're going to try another one, also polynomial. I have b, which says 5 times 2x plus 3 cubed minus 9 equals 616. So when I look at this, I notice there is only one x. So in the previous question, I had two different like terms. I had x squared and x squared, so I needed to move those to one side and collect my like terms. Here, I just have one single solitary x. So I don't need to do any collecting of like terms. I can just start rearranging to try to get x by itself. So I see a lot of different operations here. We usually start with addition and subtraction. This addition inside the bracket is inside a bracket, so I can't do anything with that, but I can try to eliminate that -9 or -9 by adding 9 to both sides. So I'm going to get 5 times 2x plus 3 squared, cubed, is 616 plus 9. That is 625. All right, so up next, I'm going to work with this multiply by 5, and I'm going to divide by 5. There's also a multiply by 2, but it is inside the bracket, so it's off limits right now. So this will give me 2x plus 3 cubed equals 625 divided by 5 is 125. From here, before I can touch anything inside the bracket, I need to deal with that bracket. The bracket is there to show that power of 3, so we're going to cancel out that power of 3 by doing a cube root, or the third root. So I get 2x plus 3 equals, now the cube root of 125 is 5. Now, the previous question, we did plus and minus, because when you have an even numbered exponent, it could be a positive number or a negative number that is getting squared to give me 16. But when it's an odd numbered root, we don't have to do the plus and minus. If this was going to be -5, that number would have been -125. So I don't need plus and minus. So from here, I'm going to continue rearranging. I want to eliminate that plus 3 by subtracting 3. So I get 2x equals 5 take away 3 is 2. And then I would finish off by dividing both sides by 2 to get that x equals 1. Okay, so I think we're going to stop there, and then you can join me in the next video to learn how to solve equations with trigonometry.